Hi everyone, welcome back to chemistry. In this video, we're going to talk about the arrangement of electrons and electron configuration. So we talked about where our neutrons and protons kind of hang out in the atom, and we said that electrons orbit around the nucleus. And the modern theory of electron behavior is actually a little bit more nuanced, or a lot more nuanced than that. And it's called quantum mechanics. So you might have heard that term before, but it makes the following statements about electrons that are in atoms. So quantum mechanics says that electrons in atoms can have only certain energies. And we say that the energies of these electrons are quantized for that reason. So what does it mean for something to be quantized? This term here, it's a little bit of a new term, so I'm bringing it down here for a second. So if we think about like a set of stairs. So say you're walking up the stairs and you can put your foot here. That's my foot here. You can put your foot here. You can put your foot here. You can put your foot here. But if you try to step here, and you probably have at some point kind of tripped over the stairs, right? What happens? Yeah, there's air there. There's nothing there. So you kind of just, you can't step there. This is how electrons are as well. They can be on this stair here, they can be on this stair here, they can be here, and so on. But they can't really be in the middle of stairs, right? So they live at these quantized, specific energies. Okay, so if the lowest stair is our lowest energy and the highest stair is our highest energy, they can jump from higher energy to lower energy, but in that case they need to be on one of the quanta. Okay, one of those stairs. Quantum mechanics also says that electrons are organized according to their energies into sets that we call shells. And these are labeled by something called the principal quantum number, which is n, or represented by the lowercase n. And we'll talk about that more in a second. But generally, the higher the energy of the shell, the farther it is from the nucleus. All right, so you see lithium here in this example has, its nucleus here. Let me actually do a different color, kind of blending in. So the lithium nucleus is right here, and you see these kind of like rings outside, and each of these rings is a shell, okay? And those shells represent the energy level. So the further out the shell, the higher the energy level. All right, so we can also divide our shells further into subshells. And the first shell has only one subshell. The second shell has two. The third has three, and so on. So if we look down here, we see our shells, right? And what do our shells tell us? Yeah, they tell us the energy level. Energy level. Whoops. That's a Y there. Of the electrons that are in that shell. So if you're in shell 1 or energy level 1, the number of subshells you have is just 1. And each of these subshells are labeled in order with the letters S, P, D, and F. So the first shell only has a 1s subshell. That's what we call it, the 1s subshell, because it only gets to S, right? It only has one subshell, and that subshell is going to be our S subshell. It's also at energy level 1, okay? So that's why it's called a 1s. And I know, just stick with me, I know this is a little bit weird at first. All right, now looking at energy level 2, right? Or shell 2. In the second shell, we have two subshells, and we call those subshells 2s and 2p. So remember, right, going in order from S to P to D to F, in our second shell, we've got two subshells, and so we get to S and we get to P. And we call those two subshells 2s and 2p because we're in energy level 2. All right, now let's take a look at the third subshell, or shell, sorry. So in the third shell, or the third energy level, right, we have three subshells. So we get our S, our P, and our D. We don't get to F in our third shell. And we call those subshells 3s, 3p, and 3d, right? We're in the third shell or third energy level, and we make it to S, P, and D subshells. All right, and then likewise for shell 4 or energy level 4, we have 4 subshells. So we make it through all of the S, P, Ds, and Fs. So we call those 4s, 4p, 4d, and 4f. So different subshells actually hold a different maximum number of electrons. So remember we said that there are 4 different subshells, S, P, D, and F. Each of them can hold a different maximum number of electrons. So the S subshell here, it can only hold a maximum of 2 electrons. The P can hold 6, D can hold 10, and F can hold 14. Okay, so looking over here at our example for lithium, when we look on the periodic table, what's lithium's atomic number? Yeah, it has atomic number equals 3, right? So what does that mean about protons? Yeah, it's got 3 protons. If it's got 3 protons, and I haven't told you that it's got an overall charge, right? It's a neutral atom. How many electrons does it have? Yeah, 3, right? These have to cancel out. So if we know that lithium has 3 total electrons, we're going to start by filling the lowest energy shell and subshell, right? The one that's closest to the nucleus here. We're going to start by filling that one with electrons. And that's what you can see here, right? There's an electron here, and there's one here. Why are there only 2? Yeah, because right now we're only in our S subshell. We haven't made it to our P, which can hold more, right? All right, so remember, this is our S subshell. And in fact, we can even be more specific and say that it is our 1s subshell. All right, the next subshell that's closest to the nucleus is actually our 2s subshell. And the reason for that is if we go up here, right, the first shell can only hold 1 subshell, and that subshell is 1s. So we have filled that shell, okay? And we can't put any more electrons there, right? So now we're going to jump to our second shell. And our second shell can hold 2 subshells, a 2s and a 2p. So let's see if we make it there. So looking at our second shell here, our second energy level, right? Now we're in energy level 2. What are we going to call this subshell? Yeah, it's going to be our 2s. 2s subshell. And in our 2s subshell, lithium, if lithium only has 3 total electrons to give, we only have 1 more electron that we can populate in that subshell, right? Because we've already used the other 2 here and here. All right, so looking back up here, right, we said, okay, lithium makes it through this first shell, right? And it fills its 1s subshell with 2 electrons, which is the total amount that the s subshell can hold. Okay, so we fill that. And now we look at our next one for lithium. Our next energy level or shell is 2, and it can hold 2s and 2p subshells. Now, we didn't make it to 2p. Why didn't we make it to 2p? Yeah, we ran out of electrons. In fact, we didn't even fill our 2s, right? Because s's can hold a max number of 2 electrons. Okay, and we only have one electron in our 2s subshell right now. This is one way that we can kind of depict the lithium atom, okay, and what it really looks like, right? What is it? Where are the electrons in relation to the nucleus? But another way, a shorthand way of writing all of this information down is with something called an electron configuration. And that's noted here. So the electron configuration for lithium can be written in shorthand as 1s2 2s1. So using our picture over here that we drew of our lithium atom, what do you think that this 1 and this 2 are indicating? Yeah, those are indicating the energy levels, right? And let me make this one a little better here. So this first number is indicating the energy level, or shell, right? That's another word for that. All right, what is the S indicating? Yeah, that's going to be the subshell, right? We said there are subshells, right? S, P, D, or F. So this particular subshell is an S subshell in energy level 1. All right, and then what do we think? I'm running out of colors here. I'll just go back to blue. What do we think that 2 here means? Yeah, that's the number of electrons in that subshell. Okay, so look over here, just looking at the 1s2 portion of this right now. So if we look over here, looking over here, right, I'm looking at my 1s subshell and I'm saying, okay, I've got 2 electrons in that 1s subshell. So that's why I've got my energy level 1, my S is my subshell, and the number of electrons in that subshell is kind of written as a superscript, or kind of almost like an exponent. All right, and then we have, right, our next energy level, which is 2, right? That's this subshell here. We get to the second energy level. We again have an S subshell, okay? And then we have how many electrons in that S subshell? Well, I'm only seeing 1, right? There's only 1 electron in that S subshell, so I'm going to put a 1 there. All right, so as always, I think this makes a lot more sense when we do an example. So let's try this out. Let's write the electron configuration for beryllium. The diagram below here might help, and the reason that it might help is that this is showing you the order that electrons are going to populate these subshells. So for instance, right, we've got some columns here. We've got 1s, 2s, 1s, 2s, 3s, 4s, 5s, 6s, 7s going down that way, right? We've also got in the next column, we've got our P's, 2, P, 3, 4, 5, 6, 7. Why don't we have a 1P here? Yeah, there's no 1P, right? For our first energy level, we only have 1 subshell, right? And that's a S subshell. Over here, we've got our D column, and over here, we've got our F column. And you can write this chart over here on an exam, just to remind yourself and not make any mistakes. And you just do that by writing in those columns first, okay? And then you're going to populate them with diagonal arrows, okay? So you're going to go this way. So first it's going to fill that 1S, so first it's going to fill that 1S subshell, then it's going to fill the 2S, then we're going to fill the 2P first, and then the 3S, and then the 3P, and then the 4S, and then it gets a little weird. You go back down to 3D, then to 4P, and to 5S. So yeah, once you get over to the D category, things get a little bit weird. But this order filling chart will help you out as long as you draw it right. So if that's a nice trick that you can have. All right, so let's first figure out, all right, we want to write the electron configuration for beryllium. So right away, I'm thinking I'm going to probably want to write something along the lines of this, right? That's an electron configuration. This is not an electron configuration. This is just a diagram to help us visually see how these atoms look and where those electrons hang out. But this is called the electron configuration, right? So let's try to, we know we're going to get something along those lines, right? 1s2, 2s something, 2p something, right? So first we need to figure out how many total electrons does beryllium have. So pause the video, try that out. All right, so beryllium is atomic number 4, which means we have 4 protons, right? If we have 4 protons, and this is a neutral atom, right, I haven't told you otherwise, then we must have 4 electrons. So beryllium has 4 electrons. So write the electron configuration for beryllium. So it's great to know how many electrons beryllium has, but as chemists, we often want to know where those electrons are in an atom, because that actually dictates how that atom is going to react and if it's going to want to bond with other atoms. So let's go ahead and try to write the electron configuration for beryllium. So thinking about beryllium, if our first energy level is always going to be 1, right? And we're always going to populate that lowest energy level first. So our first energy level is 1. What's our first subshell? What's the only subshell in our first energy level? Yeah, S. So I've got 4 total electrons to work with, and our S subshell can hold how many total electrons? Yeah, 2. So beryllium's like, all right, 2 of my electrons are going to hang out there in the 1s subshell. So we fully fill that 1s subshell. All right, and you'll notice, right? We can draw our diagonal line through here, and we know we fill our 1s subshell. All right, what's the next subshell? Looking at our diagram here, what do we expect to fill next? Yeah, our 2s subshell. So this makes sense, right? We're now going to go to the next energy level. Our first energy level only has 1 subshell, which is S, and we filled it with our 2 electrons that it can hold. So now we got to move on to the second energy level. All right, and we said that first, our S subshell in our second energy level is going to be filled, right? That's over here again, okay? And so if we have 4 total electrons, and I've already used 2 of them, what number goes here? Yeah, 2, right? For a total of 4 electrons. 2 plus 2, right? Okay, so now, yay us, we've actually drawn the electron configuration for beryllium. And the coolest thing about this, why this is so useful, is that if we see some kind of unknown atom's electron configuration, like if I just give you this on a test, you'll actually be able to figure out, oh, hey, that's beryllium. So let's practice this one more time. So write the electron configuration for carbon. So now I'm going to let you kind of try this out and pause the video and come back. All right, so for the first step, we kind of want to just figure out how many total electrons does carbon have. Well, carbon has an atomic number of 6, so it has 6 protons, so it must have 6 electrons. Okay, so that was kind of like, I don't know, step 1. Step 2. Now we want to kind of start populating our energy levels. So the first energy level that we fill is that 1s, right? So I'm going to go ahead and write 1s. Now that we kind of know the concept, right? Now we can use our hints over here. So we fill that 1s subshell with how many electrons? Yeah, 2 electrons, right? I've got 6 total to play with. We've gotten rid of 2, so we're going to keep moving along. So we make it next to 2s, right? 2s is our next one. Let me see, maybe I'll go blue over here. So we filled our 1s, and now we're filling our 2s. So I kind of gave it away, but we're going to fill our 2s. Why do we fill our 2s? We've got enough electrons, right? So how many electrons can the S subshell hold? Yeah, 2, always. Okay, S can hold 2, P can hold 6, D can hold 10, and F can hold 14. In our class, generally, we're really going to mostly deal with the first 2 subshells, but you do need to kind of, but we do want to still kind of talk about D and F a little bit. All right, so for carbon, we made it through 1s2. We made it to 2s2. What is next on our little chart here? Yeah, 2p. We get through 2p, right? So 2p. Oops, let me make that red. 2p. Now, our p subshell, we haven't really worked with it yet so far, but our p subshell can hold 6 electrons max. All right, we don't have 6 electrons. But that's okay. We'll fill it as much as we can. So we've got 6 total electrons. We already used 4 of them. So we have how many left? Yeah, 2. Okay, 2 electrons are left. So we're going to put our remaining 2 electrons in the 2p subshell. And this is the electron configuration for carbon. So notice we didn't make it to 3s, right? We didn't fill our 2p sublevel or subshell all the way. What number would be here if we did fill it all the way? Yeah, 6, because p can hold 6 max. Okay, we didn't fill it all the way though, and that's okay. So we're just going to leave it at 2p2. So if I gave you this electron configuration and I said find the element that has this electron configuration, you could count all of the electrons, 2, 4, 6, and you would know, hey, that's carbon. Why would you know that was carbon? Yeah, carbon is atomic number 6 on the periodic table, right? All right, so hopefully this is starting to make a little bit of sense. We'll definitely practice it quite a bit, but I'm going to pause the video for now and we'll come back for part 2 of talking about electrons in the next video.